Hello, Sam Grace Homeschool. I'm James, and today we're going to be doing a maths lesson looking at algebraic expressions. So, an algebraic expression is a description of certain calculations that have to be done in a certain order. In this chapter, you'll be introduced to the language of algebra. You'll also learn about expressions that appear to be different, but that produce the same results when evaluated. When we evaluate an expression, we choose or are given a value of the variable in the expression. Because now we have an actual value, we can carry out the operations, such as plus, minus, times, and divide, in the expression using this value. So these are some variables, things that, so when they speak about an expression over here, it will usually have these variables without an actual value, and then we'll either be given a value to calculate the expression, or we will have to calculate that value ourselves. Okay, so for this one, I'm not too sure what this is asking, but I'm just going to assume some things. I'm assuming that we need to fill in some symbols here, like plus, minus, times, and divide in between these things to make this true. So I would say this is x times y times z is equal to x, y, z, or y, x, z. The order doesn't matter. So this is the same. Just a quick thing. This. And guys, please draw your x's like this, because otherwise it gets confusing with the multiplication sign. This is the same as x, y, z, which could also be the same as z, y, x. So the order, when it's multiplication like this, it doesn't matter. Not too sure what to do here. Z, maybe let's see z plus y is equal to x, and that means y minus, no, I'm just kind of making this up as I'm going. Let's assume this is an equals. Okay, I'm going to change this to a subtract maybe. And let's see. So would that be the same? Let me just check. Z. If you move this to the other side, yeah, z would equal to x plus y. Okay, so I'm not sure if this is what this page of the slide wants us to do. I'm just assuming because we weren't given any instructions. So we can see that this is the same. Z minus y is equal to x, because if you take the y to the other side, you'll get z is equal to x plus y, which is what we have over here. Algebraic language. So there's words, diagrams, and symbols. Okay, complete this table. So with words, multiply a number by 2, add 6 to the answer. So here we have a flow diagram, multiply by 2 and add 6. Here we have 2 times x plus 6. Okay, and then I'll do this one over here. This one we will have, so x is the number that we're multiplying, so we'll have 5 times x. Sorry, it's quite difficult to write. 5x minus 1. Just a quick thing, we can also write 5 times x as just 5x ignoring the multiply. So this could also be written as 2x plus 6. Okay, fill up the rest of the table yourself. An algebraic expression indicates a sequence of calculations that also can be described in words or with a flow diagram. The flow diagram illustrates the order in which calculations must be done. Okay, so remember, don't do bod maths, we just times by 5 and then minus 1. So the subtract comes first, then or an addition comes first, then we would do that first in the order left to right. in algebraic language, the multiplication sign is usually omitted. So we say 2x instead of 2 times x. That's what I was saying over here. We can also write x times 2 as 2x. Write the following expressions in normal algebraic language. Okay, so this would be minus 2a, because we can omit the multiplication. So minus 2a plus b. I guess you could also write b minus 2a to make it slightly more condensed. And here we have a2, which can be written as 2a. Let's move on. Looking different, but yet the same. Complete the table by calculating the numerical values of the expressions for the values of x. Some answers for x equals 1 have been done for you as an example. Okay, so here we have the expression, and then here is what we're going to sub into the x value and then calculate it like that. So if we sub in 1, for 5x, we'll have 5 times 1, which gives us 5. We sub in 1 for 2x plus 3, we get 2 times 1, because what's happening is the 1 is replacing the x. So we have 2 times 1 plus 3, which gives us 2 times 1 gives us 2 plus 3 gives us 5. And then you can do the same. Let's sub in 10 here. So here we have 2 times 10 plus 3 times 10. So we have 20 plus 30, which gives us 50. Here we would have 5 times 10, also gives us 50. Here we have 2 times 10, which gives us 20, plus 3, which gives us 23. And here we have 5 times x squared, and here the x is 10, so 10 squared is 100. 5 times 100 gives us 500. Okay, I'll leave the rest for you guys to do. Do the expressions 2x plus 3x and 5x in question 1 above and produce different answers or the same answer for x equals 3 and x equals 10. Okay, so you must do these and figure out if these expressions give the same answer. And do the same for these expressions as well. I think it's the same. Okay, write down all the algebraic expressions in question 1 that have the same numerical value for the same values of x, although they may look different, and then justify your answer. One of the things we do in algebra is to evaluate expressions. When we evaluate an expression, we choose or are given a value of the variable in the expression. Because now we have an actual value, we can carry out the operations in the expression using this value, as in the examples given in the table. So what we did over here, algebraic expressions that have the same numerical value for the same value of x but look different are called equivalent expressions. Say whether the following statements are true or false. Explain your answers in each case. So the expressions 2x plus 3x and 5x are equivalent. So I would say that is true. And the expressions 2x plus 3 and 5x are equivalent. I would say that is false. And I want you guys to look at the table and find out why. And then consider the expressions 3x plus 2z plus y and 6xyz. What is the value of 3x plus 2z plus y for x is equal to 4, y is equal to 7, and z is equal to 10? Okay, I'm just going to write the answer down and put you guys in calculators. So we have 3 times 4, which gives us 12, plus 2 times 10, which is 20, plus y, which is 7, plus 7. So we get an answer of 39. Please check my answer and make sure I got it correct, and make sure you can do it as well. And remember, 6 xyz is the same as 6 times x times y times z. Okay, and what is the value of 6 xyz? 4, x is equal to 4, y is equal to 7, and z is equal to 10. So we have 6 times 4 times 7 times 10. And we get 1680. Are the expressions 3x plus 2z plus y and 6xyz equivalents? No. And then you must explain. To show that the two expressions in question 5 or 5a are equivalent, these ones, this one, sorry, we write 2x plus 3x is equal to 5x. We can explain why this is so by doing this. So we have 2x can be broken up into x plus x, and 3x can be broken up into x plus x plus x. And if you add all of those together, we get 5x. We say the expression 2x plus 3x simplifies to 5x. The term 3x is a product. The number 3 is called the coefficient of x. In each case below, write down an expression equivalent to the one given. Okay, I'm going to leave that for you guys to do. What is the coefficient for x squared for the expression equivalent to 3x squared, 8x squared, plus 2x squared? Okay, so we can just add them up. 3 plus 8 plus 2. 3 plus 8 is 11, plus 2 is 13. So we get 13x squared. If an expression that can be written as a sum, in an expression that can be written as a sum, the different parts of the expression are called the terms of the expression. For example, 3x, 2z, and y are the terms of the expression. So 3x plus 2z plus y. An expression can have like terms or unlike terms. So these are unlike terms. Like terms are terms that have the same variables raised to the same power. The terms 2x, 3x are examples of like terms. But so 2x, if we had an expression 2x plus, maybe not 2, let's go 3y, those are unlike terms. Also, if we have 2x plus 3x squared, those are unlike terms, because it says like terms are terms that have the same variables raised to the same power. Calculate the numerical value for 10x plus 2y, and then for x equals to 3 and y is equal to 2 by completing the empty spaces in the diagram. Okay, I'm going to leave this up to you guys. And questions B, C, and D. Actually, maybe I should just do them with you because you don't really get a memo. So you must do them first, and then I'll go through them. Calculate the numerical value. Okay. So here we have, this would be y, because you see we have 2y and we have 10x. So this would be x, 10x. So we could write this as just a bit more space, 10x plus 2y. And we know, we know x is equal to 3. So this, you can sub in a 3 over here. X is equal to 3 and y is equal to 2. So we have 10 times 3, which is 30, plus 2 times 2, which is 4. So then we get 34. What is the output value for the expression 12xy for x equals to 3 and y is equal to 2? So there we just have 12 times 3 times 2, which is 72. Are the expressions 10x plus 2y and 12xy equivalent? Let me just double check my answer for 10 times 3 plus 2 times 2. Okay, yeah, it is 34. So no. Are the terms 10x and 2y like or unlike? Unlike. Which of the following algebraic expressions do you think will give the same results? Okay, you guys must calculate these and then test the algebraic expressions you have identified for the following values of x. Okay, so these, the ones that will give the same results, you must test it for x equal to 10, x is equal to 17, and x is equal to 54. Are the terms of 6x and 4x like or unlike? Explain. Like. Because they both have the variable of just x. Are the terms 10x and 10x squared like or unlike? Unlike, because one has a variable of x and the other one has a variable of x squared. Ashraf and Hendrik have a disagreement about whether the terms 7x squared and yx cubed, I believe, I can't really see that, and 301 y cubed and x squared are like terms or not. Hendrik thinks they are not, because in the first term, x squared comes before y cubed, whereas in the second term, y cubed becomes before x cubed. Explains to Hendrik why his argument is not correct. Because if we have x squared times, remember, okay, let me write this out in full, x squared times y cubed is equal to x squared, because we can ignore the multiplication sign, x squared y cubed, and then we also have x squared times y cubed is equal to y cubed times x squared. So it doesn't matter the order of multiplication. It's the same as if you had something like 6 times 4. We can all agree that that is the same as 4 times 6. Check for yourself and you'll find both answers give us 24. Explain why the term 5ABC and 10 ACB and 15 CBA are like terms. Okay, so I've just given that explanation here. The order of multiplication does not matter. Add and subtract like terms. Rearrange terms and then combine like terms. Complete the table by evaluating the expression for the given values of x. Okay, I'm going to let you guys do that one and write down all the expressions that in the table that are equivalent. Question 3. Tim thinks that the expression 135x and 35x plus 100 are equivalent for x equal to 1. They both have the same numerical value as 135. Explain to Tim why the two expressions are not equivalent. Okay, so the two expressions are not equivalent. 135x and 35x plus 100 does not, they are not equal. But when x is equal to 1, they both do equal 135. We have already come across the commutative and associative properties of operations. We will now use these properties to help us form equivalent algebraic expressions. So the commutative property, the order in which we add or multiply does not change the answer. So a plus b is the same as b plus a, and AB is the same as BA. So that's what I was explaining on the previous page with the 6 times 4 example. If you don't remember, it's the same as 4 times 6. And that applies with variables as well. And the associative property, the way in which we group 3 or more numbers when adding or multiplying does not change the answer. So a plus b plus c is equal to a plus b plus c. And the same with multiplication. A times b times c is equal to a times b times c. Okay. You guys need to look here at the board if you're not concentrating, you're just listening to my voice, because it's kind of hard to see without by just listening to my tone of voice. Okay, so you can see how the associative property works. We find an equivalence expression by rearranging and combining like terms as shown below. Okay, you can read through that to see how we find an equivalence expression. The terms 80 and 20 are called constants. The numbers 30 and 5 are called coefficients because they have the variable next to it. They are multiplied by a variable. Brackets are used in the expression on the left to show how the like terms have been rearranged. Like terms are combined to form a single term. The terms 30x and 5x are combined to get the new term 35x, and the terms 80 and 20 are combined to form the new term 100. We say that the expression 30x plus 80 plus 5x plus 20 is simplified to a new expression 35x plus 100. And now we are asked to simplify the following expressions. So very useful trick if you have these printed out. What you can get is a highlighter or a different colored pen. This is what I used to do. And you just find the like terms first and you highlight them, put them in a box. Yeah, maybe I'll just underline them here because then I won't get rid of the plus sign. And you just group them together based on their colors afterwards. So then what you would have, you would add the greens and you would get 13 plus 6, which is 19x. I won't use green again. I realize it's not the best color. Plus 9. Sorry, no, this is 7 minus 2. So it'll be plus 5. Okay, and then you can do the same with maybe let's do this one over here. Question F. Okay, I think this is a cubed. It's kind of hard to see if I'm wrong. So I think these two are cubed. Then I think this one is squared. And then finally, I think this is just a normal constant. Okay, then we add them up. So we add up the cubed. So we 7 plus 9 is 16 m cubed. Plus, then we have m squared plus 7m squared plus our constant of 1. Okay, you don't have to use different colors. You especially don't have to use different colors with the answer, but it's helpful to use different colors to just group the terms together if you have different colored pens or highlighters. When you're not sure about whether you correctly simplified an expression, it is always advisable to check your work by evaluating the original expression and the simplified expression with some values. This is a very useful habit to have. Okay, so what you can do is let me just read this first. When you use a value of the variable in an expression, we call that substitution. Okay, so we can check this by maybe putting the value 1 in here. So we say m is equal to 1, and then we check what the answer would be for this expression, and then we check for this one. And then maybe we check with the value of m is equal to 2, and then we check for this expression and this expression. And if you're getting the same answers, then you most likely simplified it correctly. Make a simpler expression that is equivalent to the given expression. Test your answer for 3 different values of x and read your work until you get it right. Okay, so I'm going to leave that up to you guys. So to test your answer, we're going to use substitution. In questions 6 to 8 below, write down the letter representing the correct answer. Also explain why you think your answer is correct. Okay, so the sum of this expression and this expression will give us one of these. So you need to write down A, B, C, or D for questions 6 to 8. Combining like terms is a useful algebraic habit. It allows us to replace an expression with another expression that may be convenient to work with. Do the following questions to get a sense of what we are talking about. So convenient replacements. So question 1, consider the expression, a whole bunch of x's added together. What is the value of the expression in each of the following cases? Okay, so we have x equal to 2 and x equal to 50. So what you can do is you can combine like terms first and then do the substitution. Then consider this expression and what is the value of the expression in each of the following cases when x equal to 4, y is equal to 7, and z is equal to 10. when x is equal to 0, y is equal to 8, and z is equal to 22. So first combine like terms and then do the substitution. Suppose you have to evaluate 3x plus 7x for x equal to 20. Will calculating 10 times 20 give the correct answer? Explain. So yes, it will, because when you combine like terms, you'll get, when you combine the 3 and the 7, you'll get 10x. And then you can substitute x for 20, and then you'll have 10 times 20. So that is how you do it. You combine the two like terms. Suppose we evaluate the expression 3x plus 7x for x equal to 20 without first combining the like terms. We will have to do 3 calculations, namely 3 times 20. So we have subbed in x equal to 20 here. So we have 3 times 20 and plus 7 times 20. And then find the sum of those two. So 3 times 20 plus 7 times 20. 3 times 20 gives us 60. And 7 times 20 gives us 140. And then we have to add those together to get 200. But if we found like terms first, then all we have to do is 10 times 20 to get the answer of 200. There we go, 10 times 20 to get 200. So that's one calculation compared to 3 calculations. This is one way of thinking about the convenience or usefulness of simplifying an algebraic expression. Okay, question 4. The expression 5x plus 3x is given, and you are required to evaluate it for x is equal to 8. We will calculating 8 times 8 give the correct answer. Explain. Yes, because we combine the like terms here. 5x plus 3x will give us 8x. And if we sub in 8, we'll get 8 times 8, which is equal to 64. Suppose you have to evaluate 7x plus 5 for x equal to 10. Will calculating 12 times 10 give the correct answer? Explain. No, because when you combine like terms, remember, there's no, 5 is not a coefficient, it's a constant. While 7 is a coefficient because it's being multiplied with x. So you cannot just add 7x plus 5 to make it 12x. You'll need to go 7 times 10 and then plus 5. So the answer will be 75. The expression 5x plus 3 is given, and you have to evaluate it for x equal to 8. Will calculating 8 times 8 give the correct answer? No, again, because 5x plus 3 cannot be combined as like terms because they are unlike terms. So we will still have 5x plus 3, but now we have 5 times 8. Let me write it like this actually. 5 times 8, because that's the x has been given a value of 8, and then plus 3, which will give us an answer of 43. Samantha was asked to evaluate the expression 12x squared plus 2x minus 2x squared plus 8x for x equal to 12. She thought to herself that just substituting the value of x directly into the terms would require a lot of work. So she first combined the like terms as shown below. So 12x squared minus 2x squared plus 2x plus 8x. So you'll combine, again, you can get your colored pen out and you can find the x squareds, and then you can find just the x's. And when you go 12 minus 2 for the x squareds, you get 10x squared. And then in the blue, you have 2x plus 8x gives us 10x. Then for x equals to 10, Samantha found the value of 10x squared plus 10x by calculating 10 times, so this is the x here, this part here, and this one here. So we have the x squared and just the x, and then you'll find the answer to be 1,100. And then we're going to use Samantha's way of thinking for questions 7 to 9. And those will be for you guys to do. So remember, combine like terms using colors if you like, otherwise doing it in your head, and then do the substitution at the end. Again, combine like terms for this one, and then you will substitute at the end. And question 9. Okay, let's move on. Here's a worksheet for you guys to complete in your own time. And that is the end of today's lesson.